Hey guys, it's Rahul from ECDE Foundation, and today's topics in algebra we're going to discuss are prime factorization and exponents. So what is prime factorization? Well, prime factorization is showing the product of a number with all prime numbers. What are prime numbers? Prime numbers are numbers with only two factors, 1 and itself. For example, take the number 3. 3 is a prime number because the only factor it has is 1 and 3. What are composite numbers? Composite numbers are numbers that have more than two factors. For example, let's take 16. 16 has 4 times 4 and 2 times 8 and 1 times 16. Let's look at an example. Find the prime factorization of the number 21. Now, what factors does 21 have? For prime factorization, you always have to remember your multiplication tables. So what is a pair of numbers that multiply to 21? 3 and 7. Are 3 and 7 prime numbers? Yes. The only factors they have are 1 and themselves. So the prime factorization of the number 21 is 3 times 7. Let's look at another example. Let's find the prime factorization of the number 22. This one will be a bit more complex. So what is one set of factors for 32? 4 times 8. But are 4 and 8 prime numbers? No, they're not. So you have to factorize them further to find the prime factors of 32. Prime factors for 4 are 2 times 2. Prime factors for 8 are 4 times 2. So 2 and 2 are prime factors. So you can leave that alone, 2 times 2. But in the second set, 4 times 2, the 2 is a prime factor, but 4 is not. So you're going to have to factor 4 down further, which is 2 times 2. So we have 1, 2, 3, 4, 5 2's. So the prime factorization of the number 32 will be 2 times 2 times 2 times 2 times 2, or 2 to the power of 5. We will get into that later. Let's do some practice. So let's find the prime factorization of the number 16. So what's one factor pair for 16? 4 times 4. Are 4 and 4 prime factors? No. So we're going to have to factorize them further. Prime factors for 4 and 4 are 2 and 2. Are 2 and 2 prime factors? Yes. So the prime factorization of 16 will be 2 times 2 times 2 times 2, or 2 to the power of 4. Let's look at this one. 27. What is a factor pair for 27? 3 times 9. 3 is a prime factor, so we can leave that alone. But 9 isn't, so we have to factorize that further. 3 times 3 is 9. Since 3 is prime factor, we now have our prime factorization for 27. 3 times 3 times 3, which is 3 to the power of 3. This is our last practice problem. 54. Let's think of the multiplication table for 9. The first set of factors for 54 would be 9 times 6. 9 and 6 are not prime factors, so we have to factorize them further. As we did before, 3 times 3 is 9, and 2 times 3 is 6. So now we all have our prime factors. This will be 2 times 3 times 3 times 3, or 2 times 3 to the power of 3. Now here are some rules to remember. Know your multiplication tables well. That is the most key important thing when doing prime factorization. Also check to see if all of your final factors are prime numbers. If they're not, it's not a prime factorization. Now we're going to move on to our second topic, exponents. Exponents tell us how many times a number is multiplied by itself. For example, 2 to the power of 3 is equal to 2 times 2 times 2. So look at the terms here. Base and exponent. The number 2 is a base, and the number 3 is the exponent. The exponent tells us, like I said, how many times the base is being multiplied by itself. In this case, 2 is being multiplied by itself 3 times. Just a quick note. Whenever you're saying any number to the power of 2 or to the power of 3, you can say squared or cubed. So our first example, write 3 to the power of 7 as a power. When you're writing it as a power, we're just going to write it in this form. So how do we write this? Write our base 3 and 7 is exponent. That's it. Example 2. Write 5 to the power of 4 in expanded form. Expanded form is how we're writing the base multiplying by itself, which is how many, whatever the exponent is. So 5 to the power of 4 will be 5 times 5 times 5 times 5. 4 times because 4 is the exponent. More practice problems. 8 to the power of 2. So this is how we looked at in example 1. So what is our base? 8. So we write 8 first. To the power of 2. So 2 is our exponent. So we write it as like this, which is 8 to the power of 2 or 8 squared. Second, 11 cubed. As I mentioned before, you can say cube to the power of 3. So 11 is our base, and cubed is another term for to the power of 3. So it's 11 to the power of 3, which is 11 cubed. Now let's look at this one. 10 to the power of 4. We're going to have to write this in expanded form because it's given to us in exponent form or power form. So 10 is a base and 4 is the exponent. What does the exponent tell us again? How many times the base is being multiplied by itself. So we write 10 times 10 times 10 times 10. 1, 2, 3, 4. 10 to the power of 4. Here are some more important rules to remember. Any number to the power of 0 is equal to 1. Okay, so 5 to the power of 0, 7 to the power of 0, 14 to the power of 0. Whenever you see 0 as the exponent, it will always be 1. Never multiply the base by the exponent. A lot of people make this mistake. For example, here, when we were given 10 to the power of 4, some people do 10 times 4 and get 40. That is absolutely wrong. Never do that. You always multiply the base by itself, by how many ever times the exponent tells you. That's all for today with prime factorization and exponents. Thank you for watching, and I hope to see you next time.